Hi, can you all hear me? Is that loud enough? Yes. Okay. Hi, I'm Chris, and can you all please stand up? Come on then. To your feet, come on. By the way, that's very cooperative of you. Now, you've all been sitting for a while, and so it's probably good to get the blood flowing, and this also helps me to get rid of some energy. So I'm going to count from 1 to 12, and for each of those counts, I'm going to do an air squat, and I'd love it if you could do it with me, so we can get the blood flowing and we can wake up. Okay, so in case you're unfamiliar with this, 1. That's it. Aww. Just try anyway. Come on. Okay, 3, 2, 1. 1, 2, 3, 4, 5. Come on, happy face. 6, 7, 8, 9, 10, 11, 12. Thank you. You can have a seat. Thanks. So I'm going to talk about this. It's mostly about generators. There's some funny stuff along the way to get there. And I want to begin with this thought. Aside from thank you, Silverstripe, for allowing me to come here and for sponsoring, that we as PHP developers spend all the time waiting for stuff. Okay? This is such a big part of the code we write. We wait for things like database calls. We wait for things like reading and writing to files. We wait for things like using third-party APIs, making calls to them, passing the output of those calls. And it's just a lot of waiting. And that's because PHP as a language is designed to be very simple to pick up, very simple to reason about. It's designed to be top-down flow, and there are a lot of parts of the language that are, by design, synchronous and blocking. That's not a problem most of the time. PHP is an incredibly successful language because, in large part, it has been so easy to pick up and to work with, and so easy to build infrastructures around. But sometimes, we don't want to do that waiting. Sometimes we can serve more requests. Sometimes we can do more interesting things with that processing time instead of suspending execution until the thing we're waiting for happens. And this concept of maybe divvying up time across a number of tasks instead of focusing it all on one task is called asynchronicity. And while I'd love to talk about a lot of libraries and extensions that help you to do this stuff, I've got to be a little bit focused here because I want to talk not about something that you install to get this to work or something that you compile against PHP to get this to work. I want to talk about how we can write asynchronous code without extensions, just in parts of the language that have been around since PHP 5.5. Hands up, by the way, if you use in your day-to-day a version greater than PHP 5.5. It should be more. It should be more. That's scary. OK. If you've done any amount of PHP, this might look familiar to you. If you're predominantly working on PHP 5.3, this is probably more familiar to you. But the gist of it is that we can create these lists, these containers of data items called arrays, and we can iterate over them. So sometimes you have lots of different kinds of data that have a common theme to them, and you want to represent those on a web page. And so we can define arrays easy enough, we can walk over them easy enough, and if we've got a variable and we don't know if it is an array or not, we can use the very handy is_array function in PHP. But what about things that look like arrays and aren't? So take, for instance, this, where we create a new DOM document, which, if you've done a lot of JavaScript, is kind of similar to what you would expect to find when you're working with the HTML DOM through JavaScript. Essentially, we can put a bunch of HTML strings into this thing, and we can query it by tag names, get out elements, and then iterate over them. Well, this feels like an array, especially since we can use for eaches and whiles and fors and all that kind of thing. But when we say is array, we're going to get false, because it's not actually an array. Well, a trick we can use is to see if it's an instance of traversable. Now, the first time I saw this, I thought, hey, that's cool. Maybe I can make that thing. And I tried this, and my computer blew up. Because you can't actually implement that. It's implemented in a lot of internal classes, but if you try and do this in userland code, it's not going to work. The thing you're looking for is iterator. You implement iterator, and to do that, you've got to provide a few methods. You've got to provide current, next, key, rewind, and valid. Though probably you're not implementing the base array functionality that you're looking for. You're going to decorate an array. So more often than not, the iterators that you will use in the wild have constructors that accept arrays themselves. Now, the basics of what those methods do, you can look up yourself. No, just kidding. Current will return the current item that the internal pointer is pointing to. Next will return the next one. Key will show the index of the item this collection's on. Rewind will go back to the beginning. And valid will be called implicitly by PHP to check whether there is more data in the iterator. Have I got that kind of okay, Anthony? Okay, so those methods to implement that iterator interface. But when you create this new instance, you can use it pretty much like an array. All you're doing is wrapping an array in new and class name. And it still is an instance of traversable, so again, it looks and feels like an array even though it isn't. Of course, you could be a little cheaty and instead implement iterator aggregate. And what this is kind of a shortcut to implementing those 5 previous methods from the iterator interface. All you need to create for this interface is get iterator and return something else that implements either iterator aggregate or iterator itself. There are many reasons why you might want to make a custom iterator, but very few times you will need to make one that deviates from the functionality provided by one or more of these iterator implementations in the SPL. So, before you go away and start trying to make your own iterator classes and get really fancy, look at these, because they're already there, they're well tested, and they're stable. They're also sparkling, so you know they're legit. What does this have to do with generators? Generators, and specifically the parts we're going to look at concerning the yield keyword, are new to PHP 5.5. They've seen a lot of interesting and useful changes coming up in PHP 7. But generators generators at least feel, when you use them, like iterators. So let's look at some examples. Let's take reading files, for instance. You might have written code like this. Hands up if this looks kind of familiar, if you've seen something doing something like this. Fewer people than I would have hoped. What these 4 lines of code are doing are reading an input file, the file that this is written in because of that magic constant, splitting it up into individual lines, and iterating over those to create a syntax line number with a dot, and then the line that is being read, and then a page break. So this is kind of what you would do if you wanted to represent a file source code in HTML, as an example. And that file function is, interestingly enough, you could get there without using the file function if you did something like file get contents and then explode on new lines. Or if you did file open and then while not file end of file, and then f gets, and then file close, or f close. You could do those kinds of things, right? That's what file is doing pretty much inside. But if we wanted to make this a generator, we could make our own lines function. And we could say, okay, we're going to open a file handler, and then while there's still data in the file, we'll yield one of the lines. And at the end of it, we'll close that file handle. And the interesting bit is that now we use this thing by invoking that method, whereas before, we got an array stored in $lines. Now we invoke this method. And what we get is not an array, but a generator. And what PHP is doing here, which is interesting, is that whenever it sees this yield keyword, it suspends the execution of this function and returns whatever's yielded. So now each iteration of this will pull just one line out of that file and yield it to us until there are no more lines left to yield, and it'll close this, which is interesting. Now, why would we want to do this? Why would we want to go from an iterative approach of just reading everything into an array to a generative approach like this? Well, let's look at another example, sorting of arrays. And this is probably a terrible example for making generators, but it's interesting to see a lot of the features of them. This is bubble sort. What's going on here, and what you'll learn in a comp sci class about bubble sort, is that it's not a particularly efficient sorting algorithm. But what it does is that for the amount of items in an array, it loops through the array, the amount of times that there are items in the array. And it compares each item to the item next to it. If the item next to it is smaller, they swap. it keeps on doing this until all the items are in a numeric ascending order. Yeah. And hopefully a little bit faster than this, but you get the idea. The code to implement this is not difficult, and this is why this is often taught in comp sci classes, because it's very difficult to implement this kind of thing wrong. You can perhaps do it inefficiently, but there's very quick feedback to tell you whether you've done it right or not. So this example code does bubble sort. Now, we could turn this into, we could tackle this with a generator by making very few changes to this. It's basically changing out the last two lines. The last two lines. But what we're doing is now we're yielding after each pair of items is checked and perhaps swapped or left alone. Okay? In the previous one, we sorted everything all at once and then returned a whole array of items. Now we're yielding every time something is checked or changed. So to use it, we would do something like this. We put our source array into our generator function. We get out something that we can step through. And the last thing that happens is we have our fully sorted array if everything's gone right in our implementation. What's the benefit of doing this? Well, there are some things we can do with generators that we can't just do if our function's going to return a plain old array. The first is that we can send data into generators. In this case, if I wanted to play Russian roulette with my generator and randomly stop sorting midway through, I could send something like this into it. And then inside my generator, where I yield out the results for each iteration, I can accept a value that has been sent in with send. So this will return a fraction or 0. And so in this case, 0 could be equated to should not continue, and I could break out of that generator. I could get a partially sorted array, a random chance of getting that. What else could we do? Well, if we determine that, for instance, we're not getting significantly different items through each sorting pass, we can throw an exception into the generator. We could catch it by, inside the generator, putting the yield and whatever we're yielding inside a try-catch. And the type of exception here is the type of exception that's thrown into the generator. So we can get data out of it with yield. We can put data into it with send. We can throw exceptions in with throw, which makes me think that generators can be used as interruptible functions. Not just the stock standard functions we've been used to writing in PHP forever, but functions we can send data into, get data out of, and throw exceptions into. And some languages call this coroutines. Time for some code. What I want to do is I want to show you how we can use generators completely not for what they were made for, but to be able to do these kinds of cooperative things. Let me say that cooperative in this sense means that I want to create a set of tasks and allow each task to get a little bit of processing time and then to yield to the next task. That's the cooperative part of it, that each task lets go after it's done a little bit of processing. So I'll frame it in the kinds of words like a scheduler to manage those tasks and to make sure that each one's getting a little bit of processing time, and a task to do a little bit of processing each time. How would we want to use something like this? Say, for instance, we wanted to say scheduler with correct syntax is new scheduler. And then to this, we want to add a number of tasks. So I could say something like scheduler add task, and then I'll just give it a function, which will turn into a generator. And in here, I'll have a simple for loop, if I can actually type a simple for loop, 5i++. Ooh, nearly made that same mistake again. OK, now, how I'm going to frame this, because I don't really have anything meaningful that we can write in the time we have, is to say, I want this task to print something out, and then to defer back to the scheduler so that the scheduler can give time to the next task. So in this case, I could say something like print in task 1, tick, and then just have some way of seeing that it's advancing. Maybe have a new line after that. And then to make this a generator, I'll just have a yield keyword. But I'm not really interested in sending data out. I just want to be able to interrupt this function. I'll make another task just so we can see a little bit of variation on this. Oh, thank you very much for spotting that. I would have had lots of worries. Okay, I'll make this slightly different so we can see something different going on. And after I've added tasks to this, maybe I want to have a way to start the scheduler running. So I'll say something like scheduler run. Oh, that E key, hey? Something wrong with that E key. Maybe it's a little hink E. That was really unintentional, but there you go. Right. So this is the code we've got, just in a review. We're including 2 files which I haven't written anything in yet, making a scheduler, adding some tasks which do slightly different things, and then running the scheduler. Now if I go over to terminal and I run this, I'm going to get an error, because I haven't defined the scheduler or the task class. But let's define that quickly. We'll start with the scheduler, because that's the first thing we reference. And so we'll say something like class scheduler. I really am not meaning to do that. Class scheduler. OK. Now, for a scheduler, we're using 2 functions so far, add task and run. So let's make those. Public function add task. And I'll type in this so that it feels more secure. And then run. And what do we want to do here? Well, we want to have some internal storage for this. Say, for instance, we want to pretend we have a queue of tasks to do. And I just want to add that task to the queue. In fact, I make this even more explicit by saying array push this queue task. OK. Now, I don't have that property, so let me make that quickly. Queue. And that's going to be an array. All right. So now, in add task, we're just adding a task to this internal property. What does run need to do? Well, what run is going to do is it's going to step over every task within the queue, give it one little bit of processing time, and then if it's done processing, well, that's fine. But if it's not, maybe we want to add it back to the queue so that the next time around, the next cycle, we can do some more processing on it. So what does that look like in code? What about while count of this queue is greater than 0? So while there are still tasks in this, we'll get a task. And to do that, we'll use array shift, this queue, and we'll run the task. Bearing in mind we don't have that class or that method yet, but we'll get to there. Then, if it's done processing, it should probably be able to tell us. So I'll say something like if not task finished, I want to add it back. So I'll use something like this, add task. I'll put the task back in. Anyone shout out the significance of using array push and array shift? Those specifically? Yes, Aaron. Yep, but specifically those kinds of operations. There are multiple methods that I could use to put stuff in a PHP array. Why have I picked those 2? First in, first out. Yes. Good job. What was that? Devi. Sorry, those are like the only 2 names I know in here. My apologies. OK. We've got our add task, we've got our run. Again, if we run this, we're going to get an error because we don't have our task class. So let's make that. Class task. This now has 3 methods, I think. So finished, run, just 2. OK. We also need to do a constructor, though, and I'll tell you why. If we look at how we're using this again, we're saying, oh, we're not, but we should, new task. Glad I came back here. New task. We want to wrap this generator function within a class to manage the kinds of interactions that it will have with the scheduler. So add task, new task, and give it a function. The constructor, therefore, that we will have here, when I was doing this in JavaScript the other day, I actually typed constructor and wondered forever why it wasn't working. What we'll say here is if we'll just say generator, because we're passing something in. If is callable generator. And I think this is a fairly safe way to do it. Maybe it could be refined a bit. But if callable, in other words, if a function is being passed in and not an instance of a generator, then we'll just say, we'll just make that. We'll just invoke that. Yeah. Thank you. Oh, live coding is the best, hey? OK, if it's a function, we want to run it. We're assuming if it's a function that it's a function that's going to generate a generator. And then we'll store it to something like this. Generator is generator. OK, we need to make a property to house that. So I'll say something like generator Yeah. OK. Now we need two functions. The one that we called was finished, and the other one we called was run. Not actually in that order. So I'll make run first, public function run. And this is kind of simple. Generators, remember, feel like iterators, so we can use them like we would use an iterator. If we were accepting an iterator here, how would we get just one item from that? Anyone used iterators before? How would we get one item? Next. That's very good. This generator next. OK. And to tell if this is finished or not, how do you tell if an iterator is out of valid data? I even hinted at it. Come on. Return. What am I looking for? Valid, yes. Return not this generator valid. OK. Now, let's just go back and look at that code one last time. We're accepting something in. If it's a function, we'll call it, assuming it is a function that makes a generator. Otherwise, we'll just assign it to generator. We could probably do something like if not generator instance of generator, throw a table. OK, so if it's a function, we assume it makes a generator. If it's still not a generator, we throw an exception. Otherwise, we store it. Then run means just get one item from it, or run this generator for one iteration. And then finished is, OK, is there any more data hiding in this generator? Let's run this and see what we get. Oh, magic. OK, so most of this looks OK. Task 1, tick 2, task 2, tick 2, task 1, tick 3, task 2, tick 3. It's interleaving the processing of these two generator functions. But there's something a little hinky going on up here. Task 1, tick 0, task 1, tick 1. Any idea why that's happening? No, but good guess. In PHP, what's happening here, I mean, I say in PHP because the JavaScript example doesn't actually have this, but what's happening here is that current is being called and next is being called, so this generator is having two iterations called on it when it gets to this point. To get around this, we would do something like if not this has run. I'll just do it like that. Then what I want to call is not next, but current. Wow, if I can spell it. And then I want to set that to this has run. It's true. Otherwise, I want to call next. So the first time round, use current. Otherwise, for every other time, use next. I have to define this property as well. Oh my goodness. Thick. Has run and false, obviously, because the first time it hasn't run. Now, when we run this again, it should have resolved this. No, it hasn't. OK, think. If not this has run. Close call there. Yes, OK, so task 1 tick 0, task 2 tick 0, task 1 tick 1. That's looking great. Now, how many lines of code is this? This is the interesting part. About 20. About 20. About 30. OK, so in 70 lines of code, what we've created is a cooperative multitask manager for PHP without any extensions, without installing any extra libraries. We've just used generators, arguably not for what they were made for, but to be able to do things like asynchronous processing in a way that allows us to do more instead of just waiting for the next thing to happen. Back to slides. Where's my clicker? So simple, right? I know. There are people who have run with this idea. There's an organization called Icicle.io on GitHub. You can look at the code. It's pretty awesome. They have a lot of libraries. Before I go on to there, because your attention. They have a lot of libraries which facilitate this idea of doing asynchronous processing. And it is mostly built around the idea of using generators as coroutines in PHP. If you've used React PHP much, there are very similar libraries between the two, and I think they're aiming for the same goal. But Icicle is relevant for us because of generators. Here's an example of doing an HTTP server using Icicle. So you write this code, and you listen at that port. When you're running this long-running script, in your terminal, you can actually start up a browser and point it at port 8000, and you'll get hello world back. And this is based on top of the idea of using generators as coroutines. You'll see there's a yield keyword there, there's a yield keyword there. These are ways that Icicle interrupts this function in order to jam this stuff into a promise implementation in PHP and on top of an event loop. So that things like I/O and writing and reading from files and resolving addresses via DNS are done in a non-blocking, asynchronous way. Here's an example of doing something like a duplex stream. So this is useful if you want to set up an object that acts as a messenger between different functions or classes in your application. Again, it's based on top of coroutines implemented with generators, allowing you to do non-blocking communication between these things and not just wait for messages the whole time. The last and arguably the coolest thing that I want to show about Icicle is that here is a very obvious coroutine-based implementation of multiple process execution in PHP. So to get this to work, you have to support PHP 5.5 so that you have access to generators. But this specific class, worker process, you don't need any extensions to do that. When you start this, when you enqueue a task, which implements a certain interface that I won't go into detail about, when you enqueue this task and you run the event loop, what this will do is start up a separate process running side by side to the thread that this is, to the process that this is running in, and it'll execute code in parallel. So things that you would have previously waited for, even in an asynchronous environment, like slow reads to a database or reading and writing lots of files, get done in parallel and don't block this thread. In the same time that this stuff is running, you could be accepting HTTP incoming requests in this process. And they wouldn't be slowed because you were doing something else in parallel. This is the coolest thing that they're working on at the moment, and it's shaping up to be quite good. They also have a parallel implementation of this, not using processes, but using pthreads. So if you want to do this with separate processes, you could use worker process. If you want to do it with separate threads in PHP, you could use pthreads. And there are various times that you may not need that and shouldn't try it, but there are also times when you could need it. And if you do it responsibly and securely and carefully, then it could actually be quite beneficial to an environment that is already in PHP. And this stuff works in JavaScript. I heard a talk recently where the speaker mentioned JavaScript as JavaScript and decided I'm never going to say JavaScript again. I'm just going to say JavaScript. So there's that. This code mimics what I've just done in PHP, but it's in ES6. Using Babel.js to transpile it to ES5 and to implement some shims on top of ES5, this code will allow you to create generator-based cooperative multitasking in JavaScript. I can show you the setup for this. It's something like one npm install and one npm command to be able to compile this, and you can have this code working in JavaScript, which is pretty freaky. The scheduler looks pretty similar as well. Constructor, add task, which I've just called in queue over here, and run. Task, again, finished, a normal constructor, which again makes a generator. If that thing is a function, it assumes it's a generator maker, etc. And that is mathematical, that you can actually do that. These concepts aren't limited just to PHP, though it's an interesting place to be doing it. And sure, there are other really interesting ways to get parallel and asynchronous execution models in PHP, which is the subject of an equally entertaining and completely different talk. But these concepts aren't limited just to PHP. You can do them in any language that implements a generator, provided you have access to things like next and current and valid in that implementation, or something similar, like, for instance, JavaScript has something similar. It doesn't actually have those methods. You can do this in other languages, which is pretty awesome. Figuring out when to do it, well, that's kind of up to you. But that's all I got for you. Thanks.